Experiment 3. Flow over Weirs. Objectives: to determine the characteristics of open channel flow over a rectangular notch. To determine values of the discharge coefficient for a rectangular notch. Apparatus and supplies. Rectangular notch. V-notch. Stilling baffle. Water splitter. Delivery nozzle. Vernier height gauge on instrument carrier. Hydraulics bench. Setup for the experiment. Setting up the hydraulics bench. The water splitter. This is where the water will pass through to make it flow downwards. Place the water splitter onto the nozzle and secure it. After securing the water splitter, place the stilling baffle. The stilling baffle is used to make the water flow laminar. The rectangular weir. Place the weir with the rectangular notch. Screw the notch to the hydraulics bench to support the notch from the water pressure. Place the vernier height gauge to the center of the hydraulics bench and make sure it is upright. This is the locking and adjustment nuts. It is used for the rod to be stable and in place. This is the vernier scale. This is where the reading is taken. Below it is where the hook and point is placed. It serves as the basis of the datum. And this is the instrument carrier, serves as the base of the apparatus. Procedures. Open the bench control valve for the water to flow. Check if the water is stable and the experiment can now be performed. Adjust and calibrate the vernier apparatus. Using the fine adjustments, adjust the gauge until the point just touches the tip of the hook. Check if the tip touches its reflection in the surface. To achieve this, you will need to have your eye level just above the surface. Afterwards, take the reading at the vernier scale. After taking the reading, drop the ball valve. Then, set 2 liters of water as a constant discharge. Lastly, record the time required to fill the 2 liters of water.
Clean the apparatus with dry tissue or towel. Put it in a box, handle it with care, and put it in a safe place to store. Data and results. Volume is equal to 0.002 cubic meters. Time is equal to 8.275 seconds. height is equal to 0.0286 meters. Formulas and computation. The discharge is equal to volume over time. This is equal to 0.02 cubic meter over 8.275 seconds. The discharge is equal to 2.417 times 10 raised to negative 4 cubic meter per second. The discharge coefficient is 3 times the discharge over 2 times the length multiplied to the square root of 2g times h raised to 3 halves, where L is 0.03 meters and g is equal to 9.81. This is equal to 3 times 2.417 times 10 raised to negative 4 cubic meter per second, all over 2 times 0.03 meters times square root of 2 times 9.81 times 0.0286 meters raised to 3 halves. The discharge coefficient is 0.564. Sources of error. Errors in this experiment can mostly come from the student. One error can come from the reading of the vernier scale. The reading is only based on assumptions from the students, therefore causing inaccuracy in the results. Also, error can occur when the time of the discharge is recorded. It is only based on the timed assumption, therefore causing inaccuracy. Lastly, error can come from the mishandling of the equipment and wrong setup. This error should be minimized if not avoided in order to maximize the acquired result. Remarks and recommendations. A weir with triangular shaped notch can be used, also called V-notch. Conduct several trials if necessary.